just to get started, the chemical formula of water is H2O. So that means that it has one oxygen in the middle and 2 hydrogen atoms. Now, these are all covalently bonded, meaning they're sharing electrons. But since oxygen is more electronegative than hydrogen, meaning it attracts electrons more easily, oxygen will have a more negative charge because electrons are negative, and hydrogen will have a more positive charge because the oxygen is quote-unquote hogging most of the electrons. So these charges are called dipoles, denoted by this symbol. Because they're temporary, they're not set in stone, right? Because the electrons are moving around. So another thing to remember about water is that it is polar covalent, right? Now, polar covalent basically means polar because it is unequal, the sharing of electrons, and covalent is because the electrons are being shared. Now, we can go into some of the properties of water. So, water's ability to create hydrogen bonds gives it the properties of cohesion and adhesion. So, cohesion versus adhesion. Now, these are important to remember because cohesion is hydrogen bonding between two molecules of the same type. And adhesion is bonding between two molecules of different types, as you can see here, right? So now cohesion is responsible for phenomena like surface tension. So this is the property of when if you have a glass of water, then sometimes if you overfill it, the water can sit kind of on top of the glass like this, creating kind of a dome. And now this is surface tension. Now, adhesion, this could be maybe the condensation sticking to a window. Now, when all of this is combined, you get things like capillary action, which is occurring in plants. So, if you've got a plant right here, right, let's say this is the stem, these are the leaves. As water evaporates from the leaf, cohesion, which is bonding all of these other water molecules down here in the stem, is going to drag this water up as this water leaves, right? And then we also have the adhesion here, bonding the water molecules to the side. So these two combined create this sort of upwards suction of water, continuing to nourish the plant. So we can also talk more about the polarity, right? And one property that is strengthened by the polarity of water is its solubility. Basically, solubility is water's ability to dissolve solutes, anything that you put into it, right? So water's polarity means that it will also dissolve polar molecules. So an important thing to remember here is the phrase, like dissolves like. This is important to remember because water will only dissolve polar molecules, right? So these substances that have an affinity for water are called hydrophilic. And they can be dissolved in water. And substances that are called hydrophobic, again, think phobic like fear, cannot be dissolved in water because they are not polar or not ionic. Now, one more thing about water is its properties of temperature regulation. So this is done by heat of vaporization, right? So it's heat of vaporization. What this means up here is basically that water doesn't absorb heat very fast, right? So that's why if you go into the ocean in summer, it's a lot colder than the outside temperature because it's not absorbing that heat as quickly as the air is carrying it. So this helps to maintain, both of these actually help to maintain temperature, which is important for life on Earth, right? Because fish can't live in 115-degree water, but they can live in their 70-degree water, which is why the water doesn't change temperatures very easily. Now, evaporative cooling is similar, right? So you've got water. Now, the heat is beating down on this water, but what's going to evaporate? All of this is not going to evaporate. That would be very counterproductive. The only thing that's going to evaporate is this top layer right here, right, which is getting heated by the sun. Its particles start moving faster and faster and faster. And then eventually, this top layer is going to evaporate, and you're going to only be left with this cooler water, and the process begins again. So this top layer is going to evaporate. So that's why lakes just don't dry up all at once. And it's also going to help prevent the water from heating up too much again. Now, lastly, we're going to be talking about water's acidity. So water is actually at a acidity or a pH of 7, which is actually right in the middle of the pH scale. So down here is acidic. Here is basic. Water is right in the middle, sitting right in the middle of all that, right? So that's one more thing to remember, is that water is neither acidic nor basic. It is neutral. Last but not least, we have the property of freezing, right? So why does ice float on water? Even though it's literally made up of the same thing, H2O, right? This is because ice is less dense. It is actually caused by hydrogen bonds. So when water freezes, it freezes in a crystal lattice formation. It makes it less dense than water. Now, why is this important? Because if all of the ice sunk to the bottom, there would be no life in our oceans or in our lakes, right? All the ice would be at the bottom, the water would be at the top. It just wouldn't work out. So, thank you for joining me for this STEM in 7 video on the properties of water. Let me know if I missed anything or if there's anything else you guys would like to know. Again, we post videos every Friday.